Many kids love building robots and other gadgets. But did you know that it is some people's job to build and design gadgets? Meet Emma. Emma is a mechanical engineer. A mechanical engineer designs buildings and tests machines and objects for people to use. For example, mechanical engineers can design small objects like a video game controller or large machines like a refrigerator. As a mechanical engineer, Emma specializes in heat transfer. This means Emma designs and builds things that require heat to be moved from one object to another. For example, refrigerators remove heat from food inside the refrigerator and transfer it to the outside of the refrigerator. Right now, Emma works for a pharmaceutical company, which is a company that develops medications. Emma is in charge of designing a package to keep medication refrigerated when it's delivered to people's homes in hot weather. Imagine that a package with medication is delivered to someone's house. The person who delivers the package rings the doorbell, but no one is home. The person leaves the package on the doorstep. By the time the person gets home, the package has been sitting outside in the heat for 8 hours. The pharmaceutical company wants Emma to work on this project because she is an expert on heat transfer. Heat transfer is the way that heat moves from one object to another. Heat always moves from hotter objects to cooler objects. When this happens, the warmer object transfers heat to the cooler object. This makes the hotter object cool down. Emma also knows a lot about dissolving chemicals to keep things cool. Dissolving happens when one chemical mixes with another chemical so well that the two chemicals cannot be taken apart easily. For example, when you mix sugar with water, you can no longer see the sugar in the water. Sometimes chemicals need heat to dissolve. They get the heat from objects around them, making the objects get colder. Emma can use these types of reactions to cool things down. Emma decides to test whether an instant cold pack can be used to refrigerate medication. Instant cold packs are devices that dissolve chemicals and require heat from their surroundings. This means that objects around the cold packs get colder as heat transfers to the cold pack. Here is how instant cold packs work. The cold pack is made using a large bag that contains ammonium chloride, a type of salt. Inside the large bag, there is also a smaller sealed bag that contains water. If you squeeze the bag just right, the small bag of water pops, and the water and salt mix together. As the salt dissolves in the water, heat transfers to the bag from its surroundings. Emma wants to figure out if the cold pack can keep medications cool for 8 hours. She decides to make a prototype and test whether it can stay cold for that length of time. Proto means first, so a prototype is a model you make first before you make the actual device. First, Emma places the cold pack inside of a box with the medication. She squeezes the bag to start the heat transfer reaction. To collect data on how well the cold pack works, she puts a thermometer in the package. The thermometer is connected wirelessly to her phone. This way, she can check the temperature inside the package every 30 minutes. Next, Emma places the package inside of a test chamber that is set to 100 degrees Fahrenheit. That way, she can see if the package stays cool on a very hot day. Emma notices that the package stays cool for about 6 hours. However, the package didn't stay at a cool enough temperature for the full 8 hours. She decides she needs to make some changes to the package she created. Emma decides to modify or change her design by adding another cold pack to the package. Because there will be more salt dissolving in more water, more heat will be transferred. This will keep the medication cooler for longer. When she tests her modified design, she sees that it keeps the medication cold for 8 hours. Emma lets the pharmaceutical company know that they should place 2 cold packs in packages when they deliver medication. What kinds of things would you keep cool using Emma's design? Now it's your turn to be a mechanical engineer. Let's go on an adventure.